So in section 8.5, we have one little thing we can do with the binomial expansion as a sort of, it feels just like a bit of a party trick, but it says in the book this turns out to be sort of useful to various people in various ways as a thing to do. So here we go. It works like this. First of all, I'm going to take example 9, and they'd say find the first 4 powers for 1 minus x to the power of 4 to the power of 10, and we can do that. That's just straightforward binomial expansion. And now it says, okay, estimate the value of 0.975 to the power of 10. Now, that would be easy enough with the graphical calculator that we've got now, but let's just imagine we didn't have that. And, you know, we're just trying to work out, is there another way forward? Is there another way we can estimate this number just out of interest? Is there a clever way we can do it? And the answer is yes, there is. 1 minus x over 4 to the power of 10 we've been asked about, and we've been asked about 0.975 to the power of 10. Well, if those two things were equal, then 0.975 is just a little bit less than 1, right? So how much less than 1 is it? It's 0.025. So if x over 4 was 0.025, so just looking at this equation and just doing it a little bit quicker, x over 4 is 0.025, so that would mean x would have to be 0.1, okay? So if this is equal to this, 1 minus x over 4 is 0.925, 1 minus something is 0.925, that something is 0.025, so in other words, x equals 0.1. So, well, that's fair enough, but, you know, sort of what good is this? Well, let's look at our expansion. We've got that 1 minus x over 4 is equal to 1 minus 2.5x plus 2.8125x squared minus 1.875x cubed plus some other stuff. Okay? Now, if you look at this, the power on the x is getting bigger. Now, if x is a number bigger than 1, when you raise it to the power 2 and then to the power 3 and so on, the numbers get bigger. If x starts off smaller than 1, so if x is a small thing like 0.1, this x here is 0.1, this is 0.01, this is 0.0001. So by the time we get to x to the power of 4, we've got a really small number. And even when we times it by a coefficient, the contribution it's making to the total is quite small. So if we want to find an approximate value, 1 minus x over 4 to the power of 10 can be approximately equal to this as long as x is small. Okay, and in this case, x is 0.1, so that counts as small. So instead of needing all 11 terms for this expansion to the power of 10, I can just take the first few and say that all 11 terms are approximately equal to these ones as long as the x value that we're using is a small value. And in this case, that's exactly what we've done. I won't bother writing it all out here. It's written down in page 168 for you. But it turns out we get 0.77625, which they've rounded to 4 decimal places as asked by the question. Okay. Now, the big question there, of course, is, well, how small does x have to be? And that's not a question we really have to worry about. The answer is the question will tell you, right? The question you're answering will tell you how small x has got to be. And you often find things saying x is suitably small that powers of x to the power of 5 and onwards can be ignored, for example. A question might say something like that. So we don't have to worry about how small x has got to be. In practice, if we really had to do this, we'd have to ask ourselves, right, well, if we want if we want our answer to be accurate to 4 decimal places, then x has to be small enough that it's going to be smaller than 4 decimal places. You know, it has to be 0.0000 something or other. And you might even need it smaller than that because, of course, your x value is going to be times by a coefficient in the expansion. So practically, we might have to do a bit of worrying about how small x has got to be exactly, but sorry, not practically, in theory we might have to worry about it, but in practice the questions will always make sure that x is small enough that it will work. I suppose if the examiners were feeling a bit cheeky, they could sort of say, you know, find the approximate value to this and then explain why this approximate value might not be good enough or something like that. And you could say, well, it's only going to work as long as x is small enough, and we haven't checked whether x is small enough, or maybe if we wanted it to more decimal places, we'd have to have an even smaller x or something like that. So that is everything in chapter 8.